Alright everyone, so this is part 2 of my aspirin to fluorescein synthesis, and in the last video I hydrolyzed aspirin into salicylic acid. In this video I'm going to be decarboxylating salicylic acid into phenol. If you recall from the last video, I ended up making 144 grams of salicylic acid. To turn the salicylic acid into phenol, I first add 20 grams of copper oxide, followed by 20 grams of potassium carbonate. I then shake it around with the salicylic acid to fully mix it in. I then get all this mixture into a large round bottom flask. Once it's all in, I turn on the heating mantle to around 200 degrees Celsius. I then assemble a short path distillation setup. The hose you see attached to the vacuum adapter leads to a vacuum pump, which I will use to get rid of all the air that's in the apparatus. It's not exactly going to be a vacuum distillation because as soon as all the air's gone, I'm going to turn off the vacuum. It's just to get rid of all the oxygen that's in there that could react with the phenol. I also wrapped all the glass joints with Teflon pipe thread tape. You can perfectly well use sulfuric acid as the lubricant, but since I didn't want to work with strong acids, I just used PTFE tape. I also insulate the whole setup with aluminum foil. The process that's happening is very interesting. First, potassium carbonate deprotonates salicylic acid to form potassium salicylate and potassium bicarbonate. Then copper oxide comes along, strips away the CO2 from the potassium salicylate, forming copper carbonate. The potassium rearranges and forms potassium phenoxide. The potassium phenoxide then reacts with the potassium bicarbonate that we formed earlier to form phenol and regenerating the potassium carbonate. In the meantime, the copper carbonate that we formed earlier turns back into copper oxide due to thermal degradation, releasing CO2. As you can see, both our catalysts have been regenerated. The process then repeats and all the phenol is boiled out into the collection flask. The phenol we collect is not super pure, and the major impurity is phenyl salicylate, which comes from the reaction of salicylic acid with phenol. Once the phenol stops distilling over, I turn off the heat and let everything cool. I then transfer the crude phenol into a bottle for storage while I clean up the apparatus. To purify the phenol, I'm going to distill it one more time. I get all the phenol into a clean round bottom flask, and then set up another short bath distillation. You may notice that the phenol took on a light pink color during storage. I don't know why this happened, and it's probably some impurity which got oxidized. You may also have noticed that the phenol was liquid when I poured it into the flask. Normally phenol is a solid at room temperature, but this time it was a liquid. This means that there's still a bunch of water present, which is preventing the phenol from crystallizing. That's fine though, because distilling it again is going to remove the water. As it heats up, I start collecting some drops of distillate at around 100 degrees Celsius. This is mostly water and a small amount of water-phenol azeotrope. This can be discarded, but keep in mind it still contains phenol, so it can't be poured down the drain. Once the temperature reaches the boiling point of phenol, which is 182 C, I swap out the collection flask and start collecting the pure phenol. Once the distillation was over, I got it back into a clean bottle. The final yield of phenol was 55.84 grams, which corresponds to a 57% yield. Just so you know, making the phenol doesn't really require potassium carbonate and copper oxide. It can even be done just by heating it up, but the reaction is a lot more inefficient, and using copper oxide and potassium carbonate helps improve the yield. In the distillation flask, I was left with some orange-yellow oil, and I discarded this. As you can see, this time the phenol solidified in the bottle, which means that it's finally water-free. To get it out of the bottle, I just have to put it in some warm water to melt it. Anyways, that's it for this video, and in the next few parts, I'm going to be converting the phenol into 3-nitrophenol. Stay tuned.